Welcome back, friends. This is today's POTD problem of LEETCODE, which is medium one. Minimum number of swaps to make the string balancing. So we have to read the question statement. You are given a zero indexed string S of even length n. The string consists of exactly n by 2 open brackets and n by 2 closing brackets. Okay. A string is called balanced if and only if it is an empty string. It can be written as AB where both A and B are balanced strings. It can be written as C where C is a balanced string. Okay. You may swap the brackets at any two indices any number of times. Return the minimum number of swaps to make S balanced. So that is it. We have to return the minimum number of swaps which is required to make the string as balanced. Okay, so and the constraint size is 10 to the power of 6, so it's nothing but it accept its possibility and complexity is a big of n. Okay, and s of I is either open bracket or closing bracket, and n must be even, and it exactly contains n by 2 number of open brackets and n by 2 number of closing brackets, right? Okay, uh, let's understand this example one. So we have what's this? Okay, so the example is uh, like this, right? And so let's try to understand the question first. uh, with this we know it's actually not a balancer. Why? Because a string is only balanced when it is an or empty string, or it can be represented as AB, where AB are balanced. It is nothing but it can be like this one and this one. As AB are balanced, we can represent it as like AB, or it can be represented as C, where C is an empty, so which is nothing but like this. So it is also balanced. And here it is not a balanced one. Uh, so we have to make a swap. We take a zero index like for this. So this is 0, 1, 2, 3 are the indexes, right? So we swap the zeroth index with the next opening bracket. So then only we can make it as like uh, a correct pair, right? So now the string is like this, and now so here this is correct pair. So we have to go there, and which is closing one. Closing one which appears before the opening one, so we have to make a swap, right? So for that, this is the opening one, so swap happens, and now we have all as a right order, so nothing but here the string is balanced. Now how many swaps we are actually performing? Two, right? But we can do this with only one swap, like we have to swap the elements at 0th and 3rd index, then we can get this string, so which is actually balanced. So how we actually know we have to swap this number of index with this number of another number of a particular index? For that we don't have any order, but if you are, and this is just for according to the second test case. Here the the given answer is actually, but as there are three closing parentheses, so we have to make three swaps. For maximum, we have to make three swaps in order to make it as a balance, right? So first we have to choose the first zeroth index, uh, so we can get, and the next index, so we can get, and for the next one we can get. So we have to use at the maximum of three swaps, but we can do this with only two swaps. How we can do that? Uh, so if we can swap the first index and the last closing, yes, last open index. So like a pair is actually in right order if the opening parenthesis appeared before the closing parenthesis, right? Then usage of this parenthesis, right? So here we are actually getting the closing parenthesis first, so we have to make a swap. So but with what element we have to swap, right? So like now we have actually three open parentheses. Now if we use the first open parenthesis, we can get this one, and we are actually using the first parenthesis, right? So the answer is this one. Now, so in order to make it as balanced, we have to again choose the next closing one. So this is the next closing one. So now, and this is the next opening one. So we have to do, and we can get the result as like this. And now this is the next closing one. So now, yes, now there is no it is the next closing one, but there are no opening ones, right? So now the string is actually imbalanced. So you have to stop the process and return how many swaps we are done. We are done three swaps, right? So when we swap with the help of first index, we are performing three swaps. What if we are using the second open parenthesis? So so if you are using second open parenthesis, this one it becomes like second parenthesis, right? So this one. Now after that, so this is uh, the closing parenthesis, right? So for the closing parenthesis, we have to choose the nearby open parenthesis. So which is this one, and yeah, okay, okay. Now, so okay, here this is the next closing parenthesis, right? So we have to choose the open parenthesis, which is here. So here the string becomes like this one. So even it also uses three swaps, right? So what if we use the third open parenthesis? Then it becomes like this one, right? So if you use the third open parenthesis, now after that, so as this is the second parenthesis, right? Second, which is closure parenthesis, and we have to find the nearby second, like nearby open parenthesis, which is from the end. So this is from the beginning, and this is like middle, and this is from the end. We have to find the middle. So now, as this is the open parenthesis, which is close to the end, so we have to use this one, not this one. Then it becomes like this. So which is swap. So we are actually getting the answer with only two swaps, right? So with the help of this intuition, we're understanding that we have to swap the element with the like how can I say, we have to swap the closing parenthesis with the open parenthesis from the end of the string, right? Not from the begin or not choose the middle one. We have to swap it with the end of the string. Okay, this is okay. This is good one. But like for the most of the parentheses sums, we have to use the stack data structure, which allows the understanding nature, and we can understanding in a good way when we are using stack data structure. So, like if we take a stack, okay, and this is the string, right? Okay, and we already know if the string is like in this one, so it is balanced, and in this one, it is not a balanced string. So if we choose this one, like okay, if we choose this as a string, and this is my stack, and how many swaps we are actually use for this string? Only one swap, right? So okay, so in my stack, I have to iterate on the string. So in the first index, like so, whenever I'm getting the closing parenthesis, do I have to push that into the stack? And whenever I'm getting the open parenthesis, do I have to pop the stack? So it doesn't make sense, right? So like this is the correct syntax of the parenthesis, uses of parenthesis. And like when we get the open one, we have to push it into stack. And when we get the closed one, we have to pop that stack, right? So we just have to use this approach. Okay, so when we are getting the uh, open one, we have to push that into the stack. As this is the closed one, we have to increment our iterator. Now this is the open one, we have to push that into the stack. Now we have to increment our iterator, so which is end of string. Let's stop. Now the size of the stack is only one, so which might be our answer. So we have to return the size of like size of stack. So which is our answer. So if it is true, it has to be followed by this string also. Okay. So as this is open one, sorry, this is closed one, this is closed one, this is closed one. Now the iterator is actually at this index, which is third index, right? So at the third index, I'm pushing that into the stack. Okay. Now the iterator is actually incremented. Okay, so iterator incremented. Now it, which is again open one, so I have to push that, and this is also open. I have to push that, and now it is end of the string. So I have to return the size of the stack now, which is 3. So we have to perform 3 swaps, which is actually the maximum swaps which we have to use to make that they balance in string. So we have to return the minimum number of swaps. How can we remove? So by subtracting the 1 from the total size of the stack? No, it's not right. So like if we use the first test case, here we are actually getting see, whenever we are getting the open one, we have to push that into the stack. Now whenever I get in the closed one, I have to pop. Now the stack is actually empty. Now I'm getting open one. So open. So now I have to perform the swap here because even I mean the size of the stack is also 1. But when we use this way, when we subtract the 1 from the size of the stack, I'm getting 0. But yeah, we have to do the uh, swap in only one swap. but we are getting answer as zero swaps, which is not true, which is contradiction to this, right? So how can we do this? Uh, if we like we have to return for this two because only two swaps are enough for this to make into a balance. And here the answer is one because one is only enough for to make it into a balanced one. And what we have the size of the stack. So like when we are dividing it by two, so we get like two ones two. Here I'm getting one, and here one. One divided by two, which is actually zero. But okay, if we add a one to the size of the stack, then we are dividing. Then we can get the result like here one equals 2 by 2, and here we can get the result as 4 by 2, which is 2. So okay, the answer is here 2, right? And here the answer is 1, so which is true, right? And as those three are our examples, let us take another example. If we have a string like this, then how many minimum steps we have to use to make into a balanced one? To make into a balanced one, okay. So whenever we are getting the open one, we have to pop that into I mean we have to push that open one into the stack. Okay, and here and push it. Now the size of the stack is 2. We have to add 1, which is 3. 3 by 2. Now the size is actually 1. Like okay, the result is actually 1. Yes, the answer is true, right? So it requires only one step to make it today balanced. So true. And what if it is like this? Okay. So here I'm getting the open one. I have to push that into the stack. Okay. Now the size becomes only 1. 1 plus 1 divided by 2, which is 1. So I have to use only one step here. Okay. Mm, I think this is enough. Using this approach, you can get the time complexity as big of n, because we have to iterate throughout the string and we have to update our stack, right? And space complexity is also big of n, right? Because we are actually using the stack data structure. And if we are getting a string like only this one, or like only this one, no, this type of input is not allowed because he clearly mentioned there are n by 2 number of open parentheses and n by 2 number of closing parentheses, right? So if you are getting a string like this, okay, so 1 2 3 4 closing it. 1 2 3 4, okay. Is it balanced? Is it balanced one? No, it is not balanced. Oh, sorry, it is actually balanced, right? So to make it into a non-balanced, we can take this one and this one. Okay, now this is our string, and when we use the above approach, uh, will we get the answer? Let's see. This is closed parenthesis, so we don't update our stack. And this is open one, we have to update our stack. And this is closed one, so we have to pop. And this is open, and this is also open, right? And two closes, so now the stack size is 0, and one open, and one open. So the size is 1, and we have to add 1 2 and divided by 2. The answer is 1. So and simply we have to swap only this one. Okay. So I hope you understand this intuition why we are actually divided by two and add one. So it's completely depending upon the understanding the pattern behind the test cases, right? So if you are imagining the one way, which won't be a contradiction to the another way, right? So let's see the core for that approach. See here, I'm taking as this is the base condition, not a base condition, like it's one of the condition to become like a string is a balanced one. Whenever the string the is an empty string, so which is our given condition, right? So here, so that's why I'm written this line, and we have to take a stack and iterate over the string. And whenever we are getting the open one, we have to push that, and whenever we are getting the closed one, we have to pop. But when we are getting the string as a closed one first before the open one, do we have to pop the stack? Okay, it's a kind of base case, right? Like so okay, so we are getting the stack, we are getting the character as a closed one, but as we follows, whenever we are getting the closed parenthesis, we have to pop the stack, but the stack is already empty. So if we pop the stack, we get a condition as a underflow, right? Underflow, which may cause a random error, right? So we have to check before pop the stack. Like if the stack is not empty, then only we have to pop it. So that's why written here condition is, so whenever stack is not empty, then only I have to pop. Okay. Now after that I have a size of the stack, and so this is completely a mathematical line, right? So which we understand why we are written this one. Okay, let's submit it. Okay, so it's accepted, and it's not mandatory to use the stack for this, right? What we have to know how many open parentheses are actually present, uh, and we have to subtract how many actually are corrected pair in the parentheses. Like if we have this, if we have a string like this, so if we have a string like this, so okay, so the string is like this, and we have to know how many actually open parentheses are there, and in that we have to reduce the open parentheses which are actually paired in right order. You see, we have open parentheses, okay, and among them, these two are actually paired in right order, and this one also paired in right order, right? And okay, we have to use this one, right? And this one also, okay, and this one is also paired in right order, but this one is not paired in, it in right, okay, okay, this one is not paired in right order, which is open one. So as we have only one not paired open bracket, we have to take that one and add one to that and subtract divided by 2 that uh, divided that result with the 2, then we get the answer as 1. Okay, so hope you understand. So implementing this, uh, we don't need to use the stack, right? We have to use a variable in order to know the how many actually is how many actually ones are. So as we have to use a variable to track how many open parentheses are there, uh, so which are actually in not right order. So when we are getting the closed one, so we have to update, we have to increment that. Okay, and whenever we are getting the sets, as we don't, as we remove the stack, we don't use this. And whenever we are getting the else condition, we have to minimize because we are actually getting the closed one for the right open parenthesis. So that's why we actually reduce reduce the C value. And here, how many C's are there? Okay, so that's it. Fine. Yes, yeah. I'm getting the open one, so I'm also for closed one. So okay. I'm actually, do I have to decrement my value whenever I'm getting the closed one before getting the open one? Not right. So in order to use the open in order to decrement the C value, so we have to check whether we are actually whether the C size is actually greater than 0, right? So let me see. Okay, it's accepted. Okay, see here. So it's accepted. I hope you understand this problem and the intuition behind this. Okay, so if you understand, I'm happy. And thanks for watching this video.